So in this video, we are going to look at speed measurement using pulse meter. So the speed could be like speed of the conveyor you want to measure, or a speed of the material that is moving um, on rollers that you want to measure. So for example, here we have seen there is a conveyor, and on this conveyor, say a material is flowing, or itself the speed of the conveyor we want to measure. So there is a measuring wheel that has been coupled to the conveyor. So as the conveyor is moving along with the same, the wheel also moves. So to this wheel, the encoder is connected, and this encoder pulses we can take in with the pulse meter. Okay, and we can configure the pulse meter to measure the speed of this conveyor. Okay, now it will depend whether the speed you want to have is in per minute, or if the conveyor is moving very fast, it could also be meters per minute. Okay, so we can configure it based on whatever units we need. So say if we want to configure it for per minute, the units that we use for calculation should be in If you want to configure the conveyor for meters per minute, then we need to use all the units in meters, and vice versa. Any unit you can take, and with respect to those calculations, the respective scaling factor will come, and the meter will show you with respect to those. Okay, in few of the cases it is like you do calculation say in per minute, and once you do the calculation, you put the scaling factor and then you install it, and it is seen that the conveyor runs much faster, and per minutes gives you a very high speed, because of which the pulse meter overflows and it is not able to show you values. In that case, the pulse meter will show you 9999. That means the value is too large, and the speed is too large. The scaling factor is not configured properly. So in such cases, try to reduce the resolution of the speed. Say in case of you can go forward with meters, or vice versa, meters per minute. Do the calculation in meters per minute and then rearrange the scaling factor in the device and check whether the meter is giving you the proper data or not. So let's see how to calculate the scaling factor for measuring the speed. So here we consider the measuring wheel diameter. So the measuring wheel that is touching the material or the conveyor whose speed we directly want to measure. Okay, that data we need. So this measuring wheel, say, is of a 0.1 meters diameter. So let's say we will set up this thing for meters per minute calculation. Hence I am taking the wheel circumference which is touching the material as 0.1 meters, based on which if I calculate the circumference will be pi d. So pi into 0.1 meters, which comes out to be 0.3141596 meters. So once the measuring wheel rotates complete 360 degrees, 0 to 360 degree, okay, that means 0.3141596 meters, my material will go ahead, or my conveyor will move ahead. Okay, so once the circumference is calculated, we need to calculate then alpha. How alpha is calculated? Alpha will be calculated based on this formula, 60 into this factor that we just calculated, which is the circumference here for one revolution, divided by number of pulses that you are going to receive. Meaning, in this case, if your encoder A pulses we are connecting, and the encoder PPR is 500, then this N will be 500. If your PPR is 10,000, if your PPR is 1024, N will be 1024. Or instead of A, say if you are connecting Z pulse, in that case, okay, we receive 1 pulse per rotation, so N will be 1. Okay, so in our case, our meter that we are using is E48 500 3N24. That means our meter is having 500 ppr and I'm going to use a pulse, because of which at n I am using 500 for the calculation. L value already we calculated, the circumference multiply by 60. So in my case, the alpha value comes out to be 0.0377. Rounding this last three digits off, I get this value. Okay. So this value, if I want to enter inside my pulse meter, I will enter it PSCH, which is my mantissa, as 0.0377, and PSCAY, which is my exponent, as 10 raised to 0. Okay, so these are basically 0.0377 multiply by 10 raised to 0, which comes out to be this alpha value. Okay, let's say my alpha value, I can also write the same alpha value in this format. For example, I can write it like, say, 0.377 multiply by 10 raised to -1. So this is also, when I do the calculation, this was also 0.0377. But here my exponent will be then 0.377 and my mantissa will be 10 raised to -1. Okay, so for simplification here I have just kept the exponent 10 raised to 00 and my mantissa as 0.0377. So once we enter this, we can our meter is ready to measure the conveyor speed. Okay, so I am going to keep my RPM of my motor as 60 RPM. So if I keep it 60 RPM, my motor is going to rotate 60 times. So 60 times of 0.0377, that comes out to be 18849. My speed should be 18849 meters per minute. If I keep RPM as 120, my speed in that case should be 120 into 0.0377, that comes out to be 37.699 meters per minute, and vice versa for 180 it should be 56.584 meters per minute. So let us re-verify this. Let us do the configuration in pulse meter and check whether we get the correct speed or not. Okay, so let us first verify we have in the pulse meter these two values set, 0.0377 and 10 raised to 0. Okay, so let us go to the pulse meter. I'll also show you the mode here. See, the mode is F1 only. So in F1 mode itself, it can do frequency measurement, it can do RPM measurement, and it can do speed measurement. The change over here will be the alpha value. The calculation will be the main key change. So we need to verify our calculation for our RPM measurement. In parameter group 2, if we go to PSCAH, we can see our PSCAH value is 0.0377 and PSCAY is 10 raised to 00. Okay, so my scaling factor has been set for the application. So I'm going to give the RPM to the motor now. Let's say I'm going to rotate the motor at 500 RPM. So as per our calculation, the the encoder giving pulses to the pulse meter should show us 18.849 meters per minute speed. So running the motor at 60 RPM with 500 pulses, we can see we are getting speed of 18.49 as per our calculation. Let us verify at 120 RPM. So for 120 RPM, I need to give 1000 pulses. So for 1000 pulses, our RPM should be 37.699. Yeah, so we are receiving 37.6. Now same thing, to increase the RPM to 180, I am increasing the velocity 1500. So 3 rotations per second. So per minute I will get 180 RPM. Okay, so I am getting 56.4. So our calculation and our actual practical data is matching. Okay, so this is how we need to do the calculation for speed measurement in case of pulse meters.